Assalamualaikum.
Salam.
Salam.
Okay, today we are going to do a group discussion for our assignment task. So I'm going to share the question that provided to us. So for section 1.1, we are group D, right?
Yeah. Good D.
Correct.
So the assignment title is three-phase system, voltage or current or power in unbalanced star connected load. So we are required to design a three-phase system with a star connected alternator and unbalanced star connected load. Your load should consist of RL or RC combination. Discuss with group on how to calculate line of phase voltage, current and power of the system. Support design with manipulation and simulation using multi-sim. Okay, that's clear.
Clear.
So for submission in our video presentation, we are using PowerPoint slide or screen recording. I have separate our group to these three of requirement of video presentation. So first, technical briefing of the topic. I with Afiq going to do this. Okay, this clear?
Okay. Clear.
Second requirement, the design of the circuit or system supported by the manual calculation. This part I'm going to give Hadrami and Fahmi. Okay.
Yes.
Oh, so for the design of the circuit, I just show the design of the circuit and then just describe it, right?
Okay, that's right.
Okay.
Like that.
Correct.
And the manual calculation going to Fahmi, kan?
Yeah.
So the demonstration of multi-sim simulation. Lastly, we going to give to Akmal. Okay, Akmal?
Yeah.
Alright.
Ahmad.
So we'll show the measurement.
Yes.
Alright. Okay.
Okay, so maybe we can share our progress first.
Okay. Technical briefing.
Technical briefing. Okay, let's go.
Okay. Okay, you can see.
Yeah.
Okay. Faris.
So we are group B.
Yes, we are group B. And this is our assignment title, our group name, and metric numbers. Okay, next. Okay, for the slide, we put the question that we need to do. The assignment task is we are required to design a three-phase system with star connected alternator and unbalanced star connected load. So the question we take from the assignment task that I show before this, right?
Yeah.
Yeah. Okay, next. Okay, this the definition of three-phase WYE star connection. So this figure show the three-phase WYE star connection in the three single-phase AC alternator windings or motor or transformers winding are wired in parallel with the same reference lead of each winding connected one each to supply conductors L1, L2, and L3. The three-phase WYE wiring configuration is referred to as a voltage multiplier or divider. This reference comes from the three-phase AC line voltage, and it is measured between any two of the three supply line in the three-phase alternator. WYE wiring configuration. So this definition is. Can you all give your suggestion? Is it okay to use?
Yeah. Okay.
Yeah,
Yeah.
the
Is
figure is also correct.
Okay, perfect.
so
Okay.
why?
As a basic definition.
Okay. And
Okay.
let's go to Afiq to continue our technical briefing part.
Okay.
Okay.
For our task, we need to explain about three-phase unbalanced load meaning, right?
Yes.
Okay. Okay. The loads are unbalanced when each other load phase has different impedance and or power factor. In that case, current and power in each phase will be different. That's why it's called three-phase unbalance. We may come across the following three-phase unbalanced load when four wires are connected: unbalanced load, unbalanced connected load, unbalanced three-wire, and Y connected load.
Yeah.
Okay,
So these
yeah.
are the three that you you apply is the three phase unbalanced load that we
The
the
example.
three case
Yeah, three
Mm,
case.
yes, three case.
Okay.
Okay.
Okay, next.
Can go
This
through.
is different. This is
Oh,
different
different.
between three-phase balance and three-phase unbalanced system. Okay, for the three-phase balance system, waveform is perfectly sinusoidal in terms of magnitude and phase shift of 120 degree. Current flowing through each phase is same. No current flow through the natural. Power loss is very low or not present. Okay, for the three-phase unbalanced system, waveform are disturbed in terms of magnitude and phase angle. Current flowing phase is not same. Natural needed power loss are more. Okay, this is for the difference between balanced system and unbalanced system. Okay, any suggestion?
I think it's okay to use the four
For
terms of
definition.
different. Yeah.
Yeah.
Mm.
I think it's okay.
Okay, that's all from me. Next.
Okay, we can
Okay.
go through to
Calculation.
calculation and simulation.
All right. I share. So okay. This calculation I got. So we have three phase, right? So we have the ZR, ZY, and ZB. So ZR A plus J 0.314 ohm, ZY 10 ohm, ZB 8 minus 7 0.01 J 0.011 ohm. So
Okay.
to
Alright.
calculate IR, so the formula to 240. What all this? Phase,
Yeah, phase.
Phase
Phase.
angle.
phase
Good.
0 degree over 8 plus J 0.314. So they get 29.95 minus J 1.176, and we get 29.98. Phase negative 2.25 degree. Okay,
Okay.
and to calculate I by, the formula is 240 negative 120 degree over 10. So we got 12 negative 12 minus 7 20.7 J 20.785 So we get in phase 24 is minus 120 degree. So to calculate IB, current in B, 240 is 120 degree over 8 minus J 0.011. So we get negative 15 plus J 25.96, and in phase we got 30 phase 120.1 degree. So PR, the formula is IR squared times RR. So the we got IR we got 29.98 squared times 8. So we got
Yeah.
7.19 kilowatt.
Oh, this one to calculate the power of
Yes,
power of
this
R.
is
Okay.
calculate power. Sorry,
Find R.
Okay, okay,
not to
okay.
mention. So calculate PY, current times resistor. So we got 5.76 kilowatts. Power B, current B squared times resistance B. So 30 squared times 8. So we got 7.2 kilowatt. So the total power we got, so sum of this RYB, so we got 20.15 kilowatt. Okay, that's all for me. Okay.
Okay.
Okay. I get it.
Okay,
Oh,
so that's the
total.
calculation.
So the calculation we need to do in phase condition lah.
Yeah. So
Yeah.
we must find apa current and power. Right.
Alright.
Okay, next.
Next.
The simulation. Can you see?
No.
Wait. Still loading.
Not yet.
Okay.
All right.
So this Al-Hadrami part, right? To share.
Yes.
Okay.
Yeah. Akmal will be sharing it for me because it will be easier for us to do the job.
Okay.
As you can see, the first voltage supply use 240 VRMS, 50 Hz and 0 degree. For the second voltage supply, we use 240 VRMS with also 50 Hz, but the degree will be negative 120. For the third voltage supply, we use 240 VRMS, 50 Hz, but the degree will be 120. R1, R2 and R3, as you can see, R1 and R3 has the same amount, which is 8 ohm, while R2 is 10 ohm. Okay, clear?
Okay.
Okay, clear.
Okay, for the L1, the inductor, we will be using 1 millihenry, and the capacitor we will be using in the circuit is 300 millifarad. And all the circuit will be connected to one ground at the end, but also being grounded to the supply also.
Alright.
Okay.
Okay. So
Okay,
the
so
voltage supply must be connect at the ground for negative part lah.
Yeah.
yeah.
So.
Clear.
So we go through
Next.
for the simulation from Akmal.
Yeah. So I will discuss about the measurement.
Okay.
First, you need the current. I will measure the current. Okay. for this is for line R. This is for line Y. This is for line B.
Oh, okay.
Alright, can you see the measurement?
Yeah.
Yeah, so
Yeah.
Oh, okay. I see.
Okay.
So
Alright,
the
for
first
the-
multimeter for R, right?
yeah, for line
Okay.
R here
And Y,
is
then B.
and yeah.
Okay.
So for the first line, the line R, the current is 29.98,
Okay.
and then for the line Y here,
Mhm.
multimeter 2, it got 24 ampere. And then for the line B, multimeter 3, it is about 30 ampere.
Yeah.
This is for the current measurement.
Okay.
Then
Current.
yeah, for the current, then we will use multimeter to calculate the power. We use two wattmeter measurement.
Oh, okay.
So we need 2 wattmeter.
This part we want to calculate power, right?
Yes.
Okay.
Yeah, power. Alright. Can you see the measurement? The simulation?
Yeah.
Yeah.
Okay. 11.
Alright.
11.
Yeah, for the first wattmeter, it got 11.029 kilowatt, and for the second wattmeter, it got around 8.64 kilowatt.
0.64.
So
Okay.
the total for these two is around 19 kilowatt, something like that, and it is approximate like the calculation, which is above 20 kilowatt.
Tally
Yeah.
with calculation.
Yeah, it's tally the calculation. Right.
Almost
So that's
safe.
all for the. Can you guys understand?
Yes.
Yeah.
Oh,
So
So-
my suggestion for our assignment video, I think this part of simulation, Akmal, I think you must zoom it for clearly to see. I think.
Zoom the circuit.
Zoom the circuit. So we can look clearly for your attach from the multimeter.
simulation.
Alright.
Okay. So do you guys think we need to screenshot this part also to our slide?
Yes.
Oh, okay. So we put calculation part also for the slide, and we just go to record our personal part and the assignment video, right?
Yeah. It's like PowerPoint.
Personal part.
Okay, any
Okay.
suggestion? I think it's okay to
Yeah.
we go.
It's okay. Alright.
I think
Our
that's good.
simulation success. Our
Yeah,
simulation.
that's
Yeah,
the
success.
calculation.
I work with Akmal to do the simulation. Oh,
Yeah,
day
that's
and night, you know.
Yes.
Oh yeah. I remember
Big
that.
So hardworking.
Yeah, I know.
Oh,
Alright, that's all.
Okay,
yeah.
I think we can start our meeting and
Yes.
submit
Yeah.
Thank you.
on our
Yeah.
time.
Right.
Okay,
Don't
thank you,
forget
gang.
the attendance.
Yeah,
Thank
thank
you.
you.
Thank
Alright.
you.
Okay, thank you, leader. Thank you.
Okay, have a good day. Assalamualaikum.
Uh,
Waalaikumsalam.
Salam.